Hi, thanks for stopping by my poster, which is on GPM status and advances. I'm George Huffman at NASA Goddard, and my co-authors are Gail Skowronek-Jackson, Scott Brown, and Chris Kidd. My email's at the bottom in case you want to contact me directly. GPM is a joint NASA-JAXA project, and the GPM Core Observatory was launched in 2014. It's in an inclined orbit that covers a zone 65 degrees north to south. There are two sensors, the Dual Frequency Precipitation Radar, or DPR, and the GPM Microwave Imager, GMI. DPR is a 3D sensor, as shown in the figure, and gives a relatively narrow swath of data. Has two frequencies, Ka and Ku. GMI gives you a 2D look at the atmosphere and provides a wider swath. Now, the Core Observatory by itself is pretty lonely. DPR gives one snapshot every 3 days or so at the equator, GMI about one snapshot per day at the equator. So GPM asks to use data from other agencies' satellites. Currently, there are 11 passive microwave sensors, which provide 3 hourly observations, the actual data. As well, we use geosynchronous infrared observations as a last-ditch fill-in. To get to a finer time resolution, we interpolate to fill in the gaps. And the last week of IMERG is available on the SVS website as ID 4285. So what is IMERG? Well, it's the integrated multi-satellite retrievals for GPM. It has multiple runs that satisfy different user requirements for latency and accuracy. The early is 4 hours after observation time, the late 14 hours, and the final 3 months. It's on a 0.1 degree global lat-long grid with half-hourly time interval. The important thing is that the new current version 6 covers the TRIM and GPM eras, so there is data from June 2000 to the present. On the right-hand side, you see the list of data fields available from IMERG in the native file. Besides the precipitation, field 1, there's also a random error estimate, field 3, a probability of liquid precipitation, that is the phase in field 9, and a quality index, which is a more qualitative estimate of skill. So what can we do with these data? Here's an example of the 2015-2016 El Nino. The top shows fading accumulations of precipitation, and the bottom shows anomalies or variations from the seasonal climatology of the precipitation. The shades of blue in the bottom across the central Pacific show enhanced precipitation, while the shades of brown in the maritime continent in particular show dry areas. What makes this go is that now in version 6 with a 20-year IMERG record, we can compute a reasonable climatology from which to compute the anomalies that are shown. One important factor is that all 3 runs in IMERG have a complete 20-year record. We know that each run has slightly different characteristics, and so this allows you to calibrate your model or activity to the run that you're actually going to use, not having to depend on some other data set. Other uses include things like computing the diurnal cycle, either globally or in local areas. To wrap up, the data postings at Goddard cover all 3 data levels. 1, which is instrument data, 2, which is swath geophysical data, in particular precipitation, and 3, which is gridded precipitation data, including the level 2s plus IMERG. We provide related data sets, the lightning sensor on TRIM, land sea mask that we use, and so on, and value-added products computed by the archives, various formats and various time resolutions, accumulations of 3 hours, 1 day, and so on. These are cataloged at GPM NASA Gov/data/directory. We're currently at version 6. Development is proceeding on version 7. Things like mountains and polar regions for retrievals, addressing the smoothing and the morph data for IMERG, various bias issues we know, and improving error estimation. Version 7 will be released about a year from now. Thank you.